Okay, so the protein that I chose is called fibrinogen. Fibrinogen is a protein present in the blood plasma, which is this section right here. It is produced by the liver, and its main function is that it initiates the growth of blood clots and creates new blood vessels in response to injury, infections, or inflammations. This is the 3D structure of fibrinogen. Its total structure weight is 429.95 kilodaltons, and it has one unique protein chain. Down here is the sequence for the protein. This photo shows, or this slide shows the disulfide bridges. That is these highlighted segments right here on the protein. The disulfide bridges are covalent links between the sulfur atoms of two cysteine amino acids, and these are a common bond that holds the tertiary and quaternary structures together. Some other structures are the primary structure, which is the core structure of the protein. It is the peptide bonds that are single strands that link multiple amino acids together. And there's also the secondary structure, which is shown in this protein. That is the alpha helixes, which is right here, and then the beta sheets, which are right there. And those are held together by hydrogen bonding. Okay, so how does this work? How does fibrinogen help form blood clots? So when you first get a cut and you start to bleed, fibrinogen will come to the surface and send out signals to the clotting factors. The clotting factors then go through a series of events that will result in the activation of the enzyme thrombin. Thrombin will then attach to the arginine amino acids present on the fibrinogen molecule, and it will split fibrinogen into separate fibrin strands. The fibrin strands will then attach to the activated blood platelets, which are activated when fibrinogen binds to the receptors on the surface of the platelets and brings them together. That is shown right here. And those happen at the same time, those steps do. So once the plates are activated, the fibrin strands will interweave among the platelets and form the blood clot. And this whole process will repeat multiple times until enough blood clots are formed. When there are enough blood clots formed, the fibrin strands will bind back to the thrombin enzyme and to prevent it from cutting up more fibrinogen, and that will end the process of blood clotting because there will be no more thrombin to cut the fibrinogen. So that will initiate the end of the blood clots. Okay, so some more important structures to know about on the protein molecule is that these highlighted segments are the arginine amino acids, and that is where the thrombin will attach to the fibrinogen to cut it into pieces. There are also two alpha carbon protein domains that are present on this molecule. I don't have them highlighted, but the importance of these are that they increase the speed of fibrin polymerization. So the interactions between the alpha carbon domains will make it a faster process for the fibrin to form blood clots, or to form the blood clots. And then the interactions also increase the stiffness and extensibility of the blood clots. Okay, so why is fibrinogen important? Fibrinogen is important because it needs to have its balance. It needs to stay in the middle of its normal level. If it gets too high, then there becomes excessive blood clotting, which could lead to strokes and heart attacks. But if the fibrinogen level is too low, then that could lead to not enough blood clotting and severe bleeding, which could lead to some fibrinogen deficiency disorders, which are listed right here below, and those can become quite deadly. Thank you.